Hello everyone, and thank you for joining this session about accelerating Sitecore JSS applications using predictive caching and AI. So a bit about myself. I'm Ehsan Asnani. You might find it difficult to pronounce my first name, but that's okay. Many people do. I'm Sitecore Expertise Director at Valtech, and I'm really excited with AI. And I really think that AI is going to take over the humanity, maybe not so soon. And I'm one of those people who believes that AI will take the jobs of developers pretty soon. So let's get to my story. What is my problem? The way that we are caching stuff, our caching strategy, which is called reactive caching. Reactive caching because when the requests arrive at the server, it tries to retrieve the item from the cache. If there's no cache hit, then the item is cached, right? And the problem is that it's not very effective when the user behavior is not predictable, not regular, and we cannot predict it. And also, the way that we use the memory is really inefficient because we store items in the cache that probably are never going to be retrieved again until they're purged from the cache. So a lot of memory is wasted. And what I'm suggesting instead is the predictive caching. So if you have a way to predict where the user is going next, what are the next URL that the user is going to hit, then we can cache the data in advance for those URLs. And this gives us some advantages. First of all, by using AI, by training the AI models, we can actually make it work in unpredictable situations, which is the situation for most of the websites, of course. A lot of the times we don't know, we cannot make a regular pattern of user data access, right? And more efficient use of memory, because we are putting items in the memory which are most likely to be accessed, not just blindly putting them in the memory which may not be accessed, compared to the reactive caching. So why do I want to use AI for predictive caching? First of all, it's actually quite suitable for the complex and dynamic user behavior, because we will train the model with that data, and it will be very efficient in those kind of environments. And it's adaptable to the change. So the traffic on your website, as you change the content, the traffic on your website is changing all the time. So with using AI, we are kind of adaptive to that change. And accuracy, it can actually create really accurate predictions, right, about the user journey, and reduce human intervention. Because, of course, we have ways of caching, like rule-based caching, with like Nginx, which you can set rules about the caching, but that requires human intervention and updating by human beings, while we don't need it here. So what is my plan? To collect the user behavior data, which is available from various sources, prepare that data, train an AI model, and then based on that AI model, I use it to predict the next request, right? And then I will integrate this with Sitecore. And of course, we need continuous update of the model. So as we get more data, more analytics data, we can always retrain our model. And this can be automated. So the sources of the data, first of all, Sitecore CDP is a great source for data. There are session data, user journey data, user interactions. Google Analytics, a lot of websites are using that. Even server logs, which actually log the access to the pages, right? CRM systems. And any tracking tool, basically, which can provide analytics data that we can use for training our model. So now, I want to go to the next part, which is building and training a model. You have actually few options. First option is to build a model from scratch, using the tools like PyTorch, like TensorFlow, or Azure Machine Learning, or platforms like that. You can actually build a model from scratch and use the model. But the problem is, first of all, to make a model which really works and gives you accurate predictions, you need a good expertise in data science. A simple model cannot actually get you there. Excuse me. And also, you need to spend a lot of time and money to train your model before it becomes really usable. So this is a sample, for example, with the TensorFlow, which is a very simple model, which is super easy to create. It's in Python. But of course, this model will never be good for production, and you need a much more sophisticated model. So what's the other option? The other option is to use an existing service. So OpenAPI actually provides this cloud API, which gives you access to this state-of-the-art language models, the large language models. And the language model, maybe it doesn't seem related to like our purpose for prediction, but in fact it contains a lot of knowledge about the language and it understands the URL, the content of the URL, and it's very easy to use. We can fine-tune the models of the OpenAI and then use the fine-tune model to have a better performance. And there's the CLI and client libraries, which makes it very easy to work with it. So first you need to select a base model from OpenAI. You need to prepare your data, use that data to fine-tune your model, which I'll show you a bit later, and then use the fine-tune model. Right. So there are a few models existing in OpenAI, which you can start from: DaVinci, Curie, Babbage, and Ada. And your choice really depends on the actual amount of money that you want to spend. The pricing are different. The response times are different. DaVinci is the slowest. Ada is the fastest. And I personally have tried Ada, which is much, much cheaper. It's like 20 times cheaper than DaVinci, and it works fine for me. So to prepare the data, your analytic data needs to be prepared first. You need to make it in this format: a prompt and a compilation. Prompt is what you pass to the API, and the compilation is the response from the API. So, of course, this is a very simple prompt. You can add much more context to this and make more accurate predictions. So, user with this ID from this location visits this URL in this time of the day. So, what would be the next URL that user will most likely visit? And then the actual URL that you have actually extracted from your data analytics will be the compilation. And then you can use this, make the data in this format. It should be in JSON-L format, and OpenAI CLI does it for you. So it's pretty easy. So you can actually create the fine-tune model. That's the JSON-L file, which is created from the analytics after data preparation. And you pass it, and the base model, which is here, is DaVinci, that you want to start from, and it will create your own custom fine-tuned model. Right. Then you can use this model for the prediction. So this is a sample call to the API which I created. You pass the model name, right, and then you pass the prompt. So you say, let's say you hit a request at the server and say this user, it could be an anonymous user also, doesn't matter, but has visited this page. So what would be the next URL that it visit? And this is the response you get, and you can see that this is the next URL that most probably will be visited by the user. So you can still enhance and improve the accuracy of the model, first of all by validation. So from your data set, you need to split it. Use part of it for training and part of it for validation. And the hyperparameters. When you're making the call to the API, actually you can experiment with those hyperparameters. And you can adjust them to see what gives you the best and most precise results. Right? And then you can fine-tune your fine-tuned model again and again, right? So you get new data from the analytics, and then you keep, fine-tuning your model. And then we need to integrate it, of course, with the Sitecore JSS, which you have multiple options. For example, you can, this kind of caching, I was thinking mostly of the server-side rendering, because probably with SSG, you don't have this problem. But with the server-side rendering, either I can change the logic in the get server-side props to just retrieve the cache data, right? And also can cache the URL, and or by adding a middleware, right? And then you can cache the JSON also, or you can cache the HTML, depending on the actual needs. So in the end, what we gain, first of all, improve user experience, because the pages are loading faster, they have to wait less for the pages to be loaded, reduce latency, and of course increase engagement, because they have actually, reducing the latency will actually make them to engage better with your website, and more intelligent resource management. Memory, talking about memory here, which we make a much more efficient use of the memory. But of course there are considerations. First of all, the cost, right? To set up and maintain this model. Of course, I would say the cost will be less of a concern as the prices of these AI services are actually getting less and less. The complexity, of actually keeping and maintaining this model, and the data privacy concerns, because we need to train the AI model with the actual analytics data. But if you are collecting analytics data, it means that you already have addressed your privacy concern. That's it, and please stay tuned. I have actually created the code which I will publish soon, and I will try to publish an article about this, including the code samples and also the details about the fine-tuning and the hyperparameters. Thank you very much.